This is Elizabeth Shi and Sarah Rossman. We're going to be doing some testing for our EDL robot, the Guide Robot. So, as we can see, when Elizabeth steps in front of the robot, the OLED screen displays that there is an obstacle, as we would expect. When Elizabeth then walks away from the robot and is out of our bounding box, the pathway is clear, and the robot's able to recognize that. You see as I pan over, it says that our pathway is clear and we're ready to keep moving forward. In this segment, we'll be testing our robot's speed. Here we can see Elizabeth turning on the robot using the potentiometer at the left. This has a knob on the outside for ease of grip and can change speeds between 3 kilometers an hour and 6 kilometers an hour, which are normal walking speeds. Here's Elizabeth walking around campus at full speed. We know that the robot can actually hit 6 kilometers per hour because the motors that we purchased are capable of moving at 1,030 RPM. This, when converted to kilometers per hour, is about 7.9, which is higher than 6. Finally, here's Sandra showing herself turning on the robot and changing its speed. You see how she starts at a slower speed, closer to 3 kilometers per hour, and then as she turns the knob, you can see the robot start to move faster all the way up to full speed. One way to show our obstacle avoidance is to look at the OLED screen. When the robot detects an obstacle, it outputs a message saying that an obstacle has been detected, and as well as showing which way it plans to go around the obstacle. When faced with a moving obstacle, like Sandra's leg, the robot detects the obstacle, stops for 3 seconds, sees that the obstacle has passed, and continues moving forward. When faced with a stationary obstacle, such as this chair, the robot approaches the obstacle, detects it, stops for 3 seconds, sees that the obstacle has not moved, and then begins to navigate around it. In this case, it turns right and then left to avoid the chair. When no obstacle is detected, the robot continues moving forward as normal. So here you can see some of the footage from our robot battery life test. To test the robot's battery life, the team took it outside and walked around on campus to see if we could meet our requirement of 30 minutes of runtime at full speed. We are happy to report that we did meet this requirement, as shown by the timer on my phone as we were recording. We also had, in addition to the 30 minutes, a little bit of downtime in which the robot was still on, but not at full speed. This would have drained the battery further, so we are even more comfortable saying that we meet this requirement.